Hi, my name is Steve Faulkner, and I'm with the SolidWorks education team. In this video, I'll be going through the SolidWorks SAE Design and Analysis Project curriculum. The SolidWorks SAE Design Project curriculum is based around the Formula SAE competition, where students design, build, and race small open-wheel race cars. The Design Project curriculum is meant to give students some of the tools they'll need for designing a Formula SAE vehicle in SolidWorks. The curriculum touches on areas that are specifically beneficial to students who enter the Formula SAE competition, but these tools can also be very valuable to any students entering other design competitions or who have classes in engineering mechanics, heat transfer, machine design, fluid dynamics, or especially for senior projects. Example parts contained in the curriculum are from Formula SAE vehicles, but the techniques and tools can easily be applied to other projects. The curriculum contains 7 lessons. First, an introduction, and then some basics on how to use assemblies, weldments, and to use molds and surfaces. The last 3 lessons are all based around analysis, and will use Formula SAE parts to perform flow, structural, and thermal design. Lesson 1 will familiarize students with the SolidWorks software. Students will go through several tutorials on parts, drawings, and assemblies to learn the basics of how to use SolidWorks. If available to you, the students can also complete the first 6 lessons of an Introduction to Engineering Design with SolidWorks, available as a separate SolidWorks educational curriculum. Lesson 2 is about using assemblies in the context of designing a Formula SAE race car. Using the provided upright and wheel assembly model, students will learn about creating in-context parts as well as working with existing parts in an assembly. Students will use these skills to create an in-context brake pad and then add an additional instance of this brake pad to the assembly. The final skill in this lesson is learning to use the Pack and Go feature. Pack and Go is an important tool for designing Formula SAE race cars because it allows students to share designs, assemblies, and parts and not have to worry about breaking references between files. In Lesson 3, students will build a frame using weldments based upon existing SAE vehicle models. The lesson will walk students through the complete frame modeling process, from creating primary tubes based on suspension geometry, to adding structural supports, tabs for suspension mounts, and also additional tubing for engine mounts. Additionally, students will learn how to create a cut list based on the frame that they create for their vehicle. Using the cut list tool, students will be able to create drawings for each tube, which will allow them to construct their frame. In Lesson 4, students will learn about surfaces and molds using an intake assembly as an example part. The beginning of the lesson contains a brief overview of the loft feature and how it is used to create the intake runner. The majority of the lesson will then be spent learning how to use SolidWorks mold tools to create a mold for the intake runner. Students will learn basic principles for designing molds such as drafting and creating male and female components. The final result will be 2 mold halves that could then be machined and used to create a final intake runner out of carbon fiber or fiberglass. Lesson 5, 6, and 7 will focus on using SolidWorks simulation to analyze various parts that we have already used in the curriculum. In Lesson 5, students will use SolidWorks simulation to perform a thermal analysis of a rotor under braking forces. The simulation package will allow students to input forces, constraints, and thermal conditions, and then look at the stresses and thermal temperature profiles created by these forces. In Lesson 6, students will use the SolidWorks simulation package to analyze the frame they modeled previously. Students will be performing a torsional rigidity analysis, which is very common in Formula SAE and extremely important to the design of the vehicle. Students will learn how to convert their model into a beam mesh and then set forces and constraints in SolidWorks to simulate a physical torsional rigidity experiment. The final lesson, Lesson 7, will teach students how to perform a flow analysis on a sample Formula SAE intake. Students will learn how to properly prepare a model for flow analysis, and then learn how to do the proper analysis using the SolidWorks Flow simulation package. The resulting data will show students how intake geometry can affect flow into the engine. That concludes a brief overview of the SolidWorks curriculum for Formula SAE vehicle design. It contains 7 lessons and teaches students how to use SolidWorks for many critical elements of the design of a Formula SAE vehicle. For more information on the Formula SAE competition, go to students.sae.org/competitions/formula series, and for more information on how you can acquire the Formula SAE vehicle design curriculum, go to solidworks.com/education.